In the structure shown below, the sigma bond between which two atoms is due to an sp2 to sp2 overlap? A. Carbon and oxygen, B. Carbon and nitrogen, or C. Nitrogen and hydrogen. In valence bond theory, a sigma bond refers to a high electron density between two atoms due to the overlap of their valence orbitals. The only orbital used for bonding by hydrogen is an s orbital. Therefore, choice C can't be correct. Let's examine choice A. The carbon atom has a steric number of 3. There are 3 regions of high electron density around this atom. 1, 2, 3. According to valence bond theory, when the steric number is 3, then 3 of the atom's valence orbitals are hybridized. The hybrid orbitals are called sp2 orbitals. This means that the valence s in 2 of the valence p orbitals are replaced by 3 sp2 orbitals. In this structure, carbon uses one of the 3 sp2 hybrids to form a sigma bond with oxygen. The other 2 are used to form sigma bonds with the nitrogen atoms. How about oxygen? There are also 3 regions of high electron density around oxygen. Its steric number is 3. So an sp2 hybrid describes this lone pair, and the sigma bond that it forms with carbon. Therefore, the carbon to oxygen sigma bond involves an overlap of the carbon's sp2 orbital with the oxygen's sp2 orbital. Therefore, the correct answer is A. Here's a simple illustration of the idea of bonding due to overlapping atomic orbitals. Imagine this is the sp2 orbital of carbon, and that this is the sp2 orbital of oxygen. When these two overlap, what we get is called a sigma bond. Now, imagine this is the p orbital of carbon, and that this is the p orbital of oxygen. When these two overlap, what we get is called a pi bond. The double bond between carbon and oxygen is said to involve a sigma bond, which involves an sp2 to sp2 overlap, and a pi bond, which involves a p to p overlap. One difference between a sigma bond and a pi bond is that a pi bond has a node at the internuclear axis. The internuclear axis refers to the line from the nucleus of one atom to the other. When we say that there is a node here, we mean that the probability of finding the electrons described by the bond is 0 here. For sigma bonds, the internuclear axis is not a node. What about the carbon to nitrogen bond? Both nitrogen atoms in this structure have a steric number of 4. For example, this nitrogen atom has 4 regions of high electron density around it. 1, 2, 3, 4. When the steric number is 4, the hybridization is sp3. Since the hybridization of carbon is sp2, the carbon to nitrogen bond involves an sp2 to sp3 overlap.